Hello guys, welcome to Leetcode Weekly Contest 364. We'll be solving the third problem, Beautiful Towers second. Okay, read the question, pause the video, read the question, and then we can move to the solution. Okay, what the question is saying that you are giving an index array of max height of array teasers. You are you are tasked with building n towers in the coordinate line ith tower is built at the coordinate I and has heights of I. A configuration tower is beautiful if it holds the following condition. And what's the condition? So basically the height should be less than equal to the max height and greater than equal to the 1. And heights is a mountain array. Mountain array, what it is saying that for 0 to some array I, it should be all less than equal to. I mean basically it's better to explain over here. So what is a mountain array? Basically mountain array saying that for like let's say there will be different heights, right? Something like this, something like this, and something like this. So it's saying that at for any one eye it should be something like this, either it should go like this and it can be equal. So it is saying that if we'll see the condition, it is saying that for any particular eye, heights of all the j minus 1 should be less than equal to j. So that is the first part we are talking about, this part. And second is if I is greater than, or like the index is greater than I, for them it should be heights of k plus 1 should be less than equal to height of k. It can be equal. Okay, and also we can, it can have something like this as well. So this is also a valid mountain array, this is also a valid mountain array. Okay, I hope till this every question is clear. Now if we'll move to the second question, if we'll see the second question, the question is exactly the same, but the only difference is in the constraint. There we have n 10 to the power 3. Okay, so let's discuss a bit there. So let's say if total number of if n is equals to 10 to the power 3, then what can we do? Then we can easily run a loop for 10 to the power 3. Okay, so if that's the case, what we can do is for any particular index I, for any particular index I, what we can do is we can run a loop for one loop should be I plus 1, so I less than n, and I plus plus, where n is total number of buildings we have to create. Now, what we can do over here is we can initially have mx, or the maximum height, let's say mh is equals to height of I, whatever the height of I we have. Now, for I plus 1, let's like this is I, or let's say this is j, and j is equal to I plus 1, j less than, and j plus plus. So for the first, so let's say it is I, then it will be I plus 1 index, I plus 2, similarly till n minus 1. Okay, so what we have to make sure that the height of I plus 1th building should be less than equal to the height of ith building. Similarly for I plus 2, it should be less than equals to I plus 1. Then if let's say mh is the maximum height of ith building, then and then for what will be the maximum height we can take for this I plus 1th building, that should be minimum of the height mh we have, comma, whatever the height of this particular building is. So let's say if the height of ith building is was 10, and height of I plus 1th building is 5, then for I plus 1th building what can we take? Maximum height is 5, but if let's say it was 12, then also we know that we have to keep on decreasing, or either it can be equal. So at max we can take 10 from here. That's why we will be taking the minimum. So we can write something like that, that height of h plus 1 should be equals to minimum of this. And also we'll have to update minimum, because, or like the mh, because we know that moving forward we'll have to decrease the height, or that should be because every height should be less than equal to this particular height going down this fashion. So like for I plus 2, it should be maximum of height of I plus 1. So mh should also be equal to minimum of mh comma h of I. Basically I will, sorry, here it will be j, sorry, my bad. Yeah, it will be j, h of j, basically plus 1 will something like this. Okay. Now here it also be j, sorry, not I plus 1, because we are consider running the loop on j, right, from I plus 1 to this. Okay. Now what we have to return, if we'll move to the question, it was saying that we have to return maximum possible sum of height. So if it is a beautiful configuration of towers, we know how we can configure the beautiful towers by following this condition. So then what is the sum of all possible heights, sorry, sum of all the heights that we have in that particular configuration, we have to return the maximum sum possible. So one naive solution is simply for each I, for int I is equals to 0, I less than n, I plus plus. What we can do, let's say we know that this should be something like this structure, mountain should be something of this structure. So let's say we are considering this I. So what we can do, for all these indexes less than, we can make sure that this upper limit is followed, and similarly for the forward indexes, we can make sure this index is followed. So what we can do is we can run a loop. Let's say mh, or maximum height, is height of I. Okay, because we know that this is the maximum height we are talking about. So for j is equals to I minus 1, j greater than equal to 0, and j minus minus, what should be the value of j, or the sum we can take from j, obviously for, and yeah, also let's say sum is equals to, here itself sum is equals to 0. So the what the sum, or sorry, we will also be considering the ith tower, right? So it's better to take it as height of ith tower. Okay. Now what would be sum plus equals to minimum of, what is the maximum height that is allowed right now, that is mh, or what is the actual height of this jth building, h of j. Similarly, we already discussed, so like let's say if it was 12 and then we move to 10, then we should decrease the height, and also if we move to 14, then also we'll have to stick to this height 12, we can't increase it. So mh should be updated, or like following minimum of mh or height of j. Okay. Similarly, this was for this line. Similarly, what we can do is we can run a similar loop for j is equals to I plus 1 to j less than n j plus plus, and the same condition. Okay. Just remember that we will reinitialize mh over here so that it doesn't give error, because we might have decreased the height, right, while coming in this direction. So what it will give, for particular index I, for particular any particular index I, it will give what will the maximum sum. Okay, what will the maximum sum, and we can have something like that, our answer is equals to maximum of answer comma sum, and finally we can return our answer. This works fine, and question 2 will get accepted. Okay, because it will take O of n square, so question 2 will get accepted, but question 3 it will throw TLE. So now what we need, what we realize that for each index I, what we have to calculate, that what is the maximum sum on its left and what is the maximum sum from its right, and we have to follow the condition at the same time. Okay, so if somehow, like right now we are running a loop for calculating this and this as well, so in total we are running 0 to n for this I, basically n minus 1, and similarly this plus this will be almost the O of n, and this is also O of n, so overall it was taking O of n square. But if somehow we can reduce this to O of 1, and this is also reduced to O of 1, then we can have our answer in O of n. Okay, so what I am saying that right now for each I we are running a loop, but let's say for each I we have something like left of I minus 1 or left of I, and similarly right of I, representing what will be the maximum sum if we consider this particular I. Okay, what will the maximum sum if we consider this particular I, then what we can have is left of I plus right of I, and now we have already included I in left of I and right of I both, so we'll have to subtract once. What will be the height of I? So what I am saying right now is, let's say this is our height setting, h of height, and in left of I what we have, that for this particular I, let's say for this particular I, what will be the maximum sum from here to here? Okay, that we have stored. How we are calculating it, we'll see later. And similarly for right, what we are seeing that for this particular I, what will the maximum sum from here to here? I am drawing a downward arrow just to remember that for any configuration or like for any mountain, if this is the I, we go something like this. Maybe there can be some equalities like something this and this and this. But you got the idea, right? Okay. So now how we can calculate this left of I. So let's say if array is something like 2, 3, 4, 5, 6, something like this. And we have a sum array. What is the maximum sum? So initially it will be 0. For this, what it can? We can always take a building 2. Okay. Now for 3, if 3 is coming after 2 and we are moving in this direction, so can we place 3 after 2? Yes. So total sum will be 5. Can we place 4 after 3? Yes, because we want this increasing. So total sum will be 9. Can we increase? Can we keep 5? Obviously we can. So it will 14 then 20. But let's say after this, we have 3 over here. What? So what will happen? So what I am saying that let's visualize it. So it was 2, it was 3, it was 4, it was 5, it was then we have a building of height 6, and then again we have a building of height 3. Now, now till here we have this sum, right? But for this 3, we just can't put it after 6, or like we can't have a building of height 6 and then we have a building of height 3. What we'll have to do is we'll have to trim down all the buildings till we get some buildings of height less than equal to 3. Okay, so what I'm saying that all the buildings we have should at max for this particular I. Just give me a moment, I'll change the color. So for this particular 3, right, we can have the buildings of height at most 3, at most 3. Okay, so at most we can have the buildings of height 3. So what we have to find out, the very first building which has the height equal to its current height, then these buildings can have a maximum height of, we already know that these buildings have height greater than the current heights. So current height is 3, and we know that this building and this building, these 3 buildings have height greater than equal to 3. But at max we can take only 3. So what we can do is for these buildings we can mark it as height 3, 3 and 3. And for this building I already have the sum, and that is 5. And we know that for this 3 buildings we can take at max 3. So what we can do is, what will be the sum over here? That the total sum at the building which was just less than equal to this current height, that is 5. Then the sum over here will be 5 plus, now we know that there are 3 buildings whose height is greater than equal to 3. So for those 3 buildings we can replace those with the buildings with height 3 itself, height 3 itself. So there are 3 buildings. The number of buildings multiplied by the maximum height, that is 3, plus whatever the current height this building has, that is 3. In total, we can find the height for this particular building. Okay, so seeing here, you will realize that we are doing nothing but we are finding an element which is smaller than equal to element in the left which is smaller than equal to the current element. That's it. So the first element which is less than equal to, basically less than equal to the current element. That's it. So now the question has reduced to very simple. For any particular index I, we will find what is the smallest or what is the largest index or the nearest element on its left, such that height of h of I is greater than equal to height of h of j. Okay, that we need to find. And now we know that if once we have the difference, then we can simply, the sum of I, we can simply write it as, sum of I can simply be written as, so let's say for the jth it was less than equal to, so the whatever the sum at j. Now we need to also count how many indices are in between. So the number of indices between, I and j, I to j, can always be found by I minus j. So what I'm saying that, let's say if at 2 position and I is 4, so there will be let's say it's 5. So in there, in between we have this will also be equal to the maximum height, and we also have to trim down to the maximum height. So in total 5 minus 2, that is I minus j, will give the number of buildings which have to be of height, the current height whatever we are talking at ith position. So that will be sum of j plus the total number of buildings we have, that is j minus, sorry, I minus j, and multiplied by the height of I, because we want to reduce them to the this height. Similarly, but if in some scenario, let's say there was no building, so it's something like this. So that what we'll have to do, then we can simply just keep on adding, okay, and yeah, so we'll keep on adding if there is no such. So now what we can do, sorry, I mistake. So let's say I don't want to just explain this. I wanted to say, let's say if it was something like this one. Now, for this particular building, we don't have any building whose height is less than this building. So for this, we can simply write whatever the index it has plus 1, because we are following zero based index, right? Multiplied by the height of ith building. So it will give the total sum over here. So what what we can do to find out the nearest, the smaller element on the left, we can simply run a while loop and use a stack. Okay, so we'll make a stack. Let's say we have a stack, or let's say we have a stack. Okay, then what we can do, let's say we have 2 3 4, then 3 again. So what we can do, first of all, we will see if the stack is empty, we won't do anything, and we can simply multiply the sum of this will be equal to position, its position multiplied by its value. Okay, position is 0 1 2 3, or if you want, let's better have this array 0 1 2 3. Okay, so for this 0th position we have some 0 plus 1 multiplied by 2, that is 2. For this 3 we will check, and yeah, we'll push 2 into the stack. Now we'll check if this 3 is greater than this, or it's better, we will have a while loop, something like this: while not s dot empty, because if it's empty we don't need to check anything, and we know that if the previous element was greater than the current element, then only we will have to trim that. So if height of s dot top s dot top is greater than the current height, that is height of I, then what we have to do, we have to remove the element. So we can simply write s dot pop. Okay, else if it's not the case, then we can simply push this element, or like whatever this current element we have, we can push it on top of it, we can push the element on top of it, and then we can move forward. So once this loop has completed, what we can do is we can simply check what is the index on the top. If it is empty, then we know that it should be I plus 1 multiplied by whatever the value it has, but right now it is index, sorry, here we will put the index, so index will be 0. So this condition false, though s is not empty, but s dot top is 2, h of 0 is 2, and h of I is 3, because we are checking for 3 now. So we it will condition will be false, and we'll check what is the top index, it will be 0, current index 1, so difference will be 1, and we know that whatever the difference comes, so this will basically, this is our I and this is our j, as we discussed in the example. So sum of I, we know sum of I should be equal to sum of j plus j minus I times of height of I. So using this, what we can have for this current index I, we can have sum as sum of j was 2, because j is 0 over here. So sum of j was 2, and the difference j here, it will be I minus j. Okay, I is 1, j is 0, the difference is 1, and current height is 3, so the sum will be 5. So, 5. Similarly, for index 2, it is greater than previous element, so the sum will be equal to 9. Now, once we have 3 over here, then, and also we'll keep pushing, so in this element. So when we have 3, now this index is greater than equal to 3. This, then what we'll do? We'll just pop it. So we'll pop this element from here. Now we have only 1 and 0. This is the condition satisfy? No, condition fails. Now we'll check the top element. The differences, the current element I will be equals to 3 and the rj becomes 1. So the sum of 1 is 5 plus the difference is 3 minus 1, that is equals to 2. Okay, and 2 multiplied by the current heights, and also you will see over here the difference is 2 because there will be two buildings that we need to consider that can maximum height of hi. Okay, so we can have the sum of 5 plus 2 multiplied by 3, that is 11 6. So 5 plus 6 is equals to 11. So I hope how we are calculating this is clear to you. Now this was to calculate left. Similarly, what we can do for the right, we can simply reverse the array, then we can calculate the sum and then again reverse the array. So in this way we can have our left array and right array. As for instance, left of I will denote what will be the maximum sum that we can get for any index I that will follow mountain structure from the left. Similarly, right will say what will be the maximum sum we can get for I if it follow mountain structure from the right. So with each I, we are including ith position both times. So the left also we have calculated the I, for the right also we have calculated the, sorry, considered the value ith. So ith will be considered twice because we know that for the ith maximum height will also always be h of I. So the contribution of ith element is twice. So what we can do is we can simply add left of I plus right of I, and we can subtract the height of I so that the contribution of ith element becomes one time, and out of for all index I, whatever the maximum value of this ith this expression will be, that will be our answer. Okay, I hope the solution will be clear. Let's go to the code once. So what? Okay, yeah, I have converted this again into ll because it was throwing signed integer overflow. Okay, integer overflow error was there, so I have converted them to vector of ll. Okay, now we have vector m, that is we are talking about. Just reverse it so that we can calculate left and right. So we have calculated left. Okay, then right, and see we have reversed the right. Right was nothing but the same array. Right, I mean rm, then we have reversed rm, and then we have calculated the right using this rm, and then again we have calculated the reversed right so that the order should be same. Okay, and then finally we are running a loop and we are returning our answer. Now coming to how we are finding the sum for any particular index I, what we are doing is we have simply make a stack, and then we have run a loop while not stack.empty, whatever the condition we have discussed in the video or the solutioning itself. So till the point if it's the previous element is greater than the current element, then we are just keep popping it. Once we reach the end, we just calculate to the difference, and if there is no difference or the no element in the stack, then we have I plus 1 multiplied by the current value, else we have whatever the element at the top, the sum till that position, and the difference multiplied by the current height, and finally we are returning this sum array. Okay, so let's try submitting the solution. Okay, it's an easy solution. I hope this question will be clear to you. If you guys have any doubt, please do ask in the comment section. Thank you.